cost cutting on labor is not abstract here. It shows up in muscle memory and habit and procedure, and on the day a complex piece of maintenance goes wrong, it shows up in the difference between catching a mistake and not catching one. The reactor at the heart of the disaster was a unit known as Reactor 6 in Plant 5 of the complex. It produced high-density polyethylene, the plastic used to make bottles and containers. Inside it, ethylene, isobutane, hydrogen, and other chemicals were heated to 230 degrees Fahrenheit at a pressure of around 600 pounds per square inch. Under those conditions, plastic particles formed and settled into a set of 6 pipes called settling legs. Over time, the particles would clog those legs. They had to be cleared by hand while the reactor itself kept running. This was the routine the maintenance crew was carrying out on the day of the disaster. The procedure for cleaning a settling leg had 2 safety steps that mattered most. First, a top valve was closed to seal the leg off from the reactor's contents. The valve was held closed by 2 air hoses, and a physical lockout device was placed on it as a final guarantee that it could not be reopened by accident. Only then could the leg be opened from below and the plastic cleared out. The whole procedure depended on those 2 air hoses being identifiable. One supplied air, one discharged air. If you swapped them, you could open the valve when you thought you were keeping it closed. The 2 hoses, by design, were identical. That is the design flaw at the center of the disaster. The control system relied on a worker remembering which hose went where. There was no physical distinction. There was no fail-safe that would prevent a reversal. If a person, contractor or not, hooked them up backwards, the valve